Welcome back to Monday Mod Tips. I'm Captain Xavier, and the next number of videos in this series are going to be the very basics of electric circuits. I realize that a lot of people that are just getting into this hobby and are wanting to start modifying their blasters often don't have any actual background or knowledge of how circuits work. And if you have no knowledge in something, it makes it actually quite difficult to start learning it, because you don't even know what questions to ask and you don't know what things you don't know, and it makes it difficult to, people will say, well, just go Google it. Well, I don't know what to Google, so where do I even start? This series are for those people, to give just a basic overview of how a circuit works and how the circuits that we typically see in Nerf blasters work, and why we do what we do, and how to do it properly, and how to understand what does work and doesn't work, and what makes a difference and what doesn't. And so we'll start with this one, which is just, what is a circuit? A circuit is a path that allows the flow of electrons from one side of the battery to the other. Usually it's going to be some form of wire that connects the two. And quite commonly there will be switches and motors or LEDs or other components that are on that wire, on that circuit, that provide resistance. But on the simplest form, it's simply a path that allows the electrons to flow from one side to the other. Now, if you simply connect them directly up, which I'm not going to do, if you simply have the positive directly to the negative and there isn't anything on the circuit that provides resistance, that is what is referred to as a short circuit. And it's bad because it allows all of the electrons to go at once. And worst case scenario, you simply drain your batteries. In the case of alkaline batteries, they don't have enough current to really be dangerous. They'll warm up a little bit, but you will drain them pretty much instantly, and then you'll have to replace them, and it won't do you any good. If you create a short circuit in something that's running on the higher powered batteries, like IMRs or LiPos, it can have catastrophic results in that it can start fires, it can slag components in your blaster, your wires can get melted, your switches can get destroyed, even your motors can get ruined. And you run the risk of the battery actually combusting or being destroyed and ruined. And that is something that you need to be very careful in when you're starting to learn circuits. And you need to be very aware of where the flow of electrons is going to go when you connect one wire to any other thing. If you connect it to a part of the switch, is it the right part? Is this going to create a short circuit when I push the switch or when I immediately plug the battery in? And that's why you should do a lot of research before you start dabbling in things that use higher end batteries, because the risk of short circuit is fairly significant. And you really don't want to mess around with that when you're using the more powerful batteries. You should never test your circuit with your LiPo battery or with any kind of powerful battery. You should have a battery pack that is made up of alkaline batteries that is the correct voltage, but that doesn't have the risk of catastrophic failure, and you test your circuit with that first and make sure that you don't have any shorts, and then you can plug in your LiPo and test it properly. So that is the basics. A circuit is something that allows the flow of electrons. We will now start looking into adding the components and how that alters the path and how that can create the path or disconnect the path. And we'll look at things that create resistance, that provide the resistance, that are then going to be the things that are going to be using that flow of electrons to create the effects that we want. So that was the basics of a circuit. Now we'll go on to the next one. Hope this was helpful. Thank you for watching.